This is Professor Daresh, and in this video we're going to take another look at polynomial division from the lens of polynomial multiplication. So let's start by taking a look at an example of polynomial multiplication. We're familiar with multiplying polynomials as either monomials, binomials, or trinomials. So for this example, I'm going to use a binomial and I'm going to multiply it to a trinomial. And I'm going to show each step, and I'm going to structure it in a really specific way to help explain the structure and meaning behind polynomial division. So here, I'm going to do x times x squared, x times negative x, x times 4, and then I'm going to start a new row for the new term, and I'm going to align vertically the like terms. So here, I'm going to do 3 times x squared, and align it with my previous x squared term. Then I'm going to do 3 times negative x, and then I'm going to do 3 times 4. Finally, for my third row, I'm going to add these common terms together. So how does this relate to polynomial division? Division, mathematically speaking, is the opposite operation of multiplication. We're basically unmultiplying two expressions. So if we look at this problem and we write it in reverse, we can consider it to be x cubed plus 2x squared plus x plus 12 divided by x plus 3. What we're basically doing here is saying, what was x plus 3 multiplied by to produce x cubed plus 2x squared plus x plus 12? We know the answer because we just did this multiplication, but how could we answer this question without knowing the answer? The first step is pretty straightforward. The only way to get an x cubed when you're multiplying an x is to have x times x squared. So I know my answer is going to begin with x squared. Let's start the structure for polynomial division and see if we can connect each step of the division process to a step in the multiplication process. Starting here, what did I multiply x by to get x cubed? That answer is x squared. Well, in multiplication, when I'm multiplying x plus 3 by some polynomial, I'm not just multiplying the x to the x squared, I'm multiplying the x to the x squared and the 3 to the x squared. And you can see that step in my multiplication when I did x times x squared, and in the second row, I did 3 times x squared. So that's what I'm going to do here in my division. I'm going to say, okay, I know that x plus 3 is multiplied by an x squared. What do I get when it's multiplied by an x squared? I get x cubed plus 3x squared. Well, now here's what I have. An x cubed plus a 3x squared, but what I want is an x cubed plus a 2x squared. What's the difference between the 3x squared that I currently have and the 2x squared that I want in my final solution? So I subtract to figure out what I need to combine with the 3x squared to produce a 2x squared. And I find, oh, I need a negative 1x squared. You can see that negative 1x squared here in our multiplication problem, because negative 1x squared plus 3x squared is 2x squared. And again, I'm doing this in reverse. 3x squared plus what can get me my 2x squared? Oh, it's a negative 1. Well, then I go back to, what did I multiply x plus 3 by to create a negative 1x squared that can combine with that 3x squared? Well, I must have multiplied the x by a negative 1x to produce negative 1x squared. It's the only way for that term to come about. And it's true. I multiplied x by negative 1x to create the negative x squared term. But when I'm doing polynomial multiplication, I don't just multiply the x to the negative 1x. I have to multiply the x and the 3 to the negative 1x in two different steps. So here, I'm going to go ahead and multiply those, and I'm going to get negative 1x squared and negative 3x. Let's bring down these terms. And again, I want an x in my final solution. But when I multiplied the negative 1x with the x and the 3, I got negative 3x. What do I need to add to negative 3x to turn it into an x? What's the missing difference between this term and this term? Check out in my multiplication. I can see that I got the x term that I desire by taking negative 3x and combining it with 4x. So that's what's missing here. Now watch what happens when I subtract these terms to find the difference. Remember, subtracting a negative ends up being addition. So that's why I'm writing plus signs here. I get x plus 3x is 4x. I need a 4x as my next term in my polynomial multiplication for this to work out. Well, what do you multiply x by to get a 4x? You multiply it by 4. Except if you were multiplying this times this, you wouldn't just do x times 4, you would do 3 times 4 as well. So we'll do that and we'll find the difference. 4 times x and 4 times 3. As we can see, there is no remainder because x cubed plus 2x squared plus x plus 12 divided by x plus 3 is x squared minus x plus 4. To say that in reverse, x plus 3 times x squared minus x plus 4 will produce this polynomial. Let's take a look at another polynomial division problem, but this time we won't do the associated multiplication first. We'll truly be asking ourselves, what did I multiply to produce this result? So for our next example, and I'm just going to space it out a little bit. Start here. We're going to divide x cubed plus 2x squared minus 3x plus 4 by x minus 7. We're asking ourselves, what do we multiply x minus 7 by to produce this result? If it helps, we can set up an unknown multiplication problem on the side and really kind of get that visual to help us think about it. So in this visual, we need to multiply the x to something that will produce the x cubed in front. Can you think of the something that goes here? Well, that should be x squared. Let's check. X times x squared is x cubed. But we can't just multiply the x by the x squared. We have to multiply the negative 7 by the x squared as well. And that gets us negative 7x squared. Do we want a negative 7x squared in our final answer? No, we want a 2x squared in our final answer. Well, what's the difference between negative 7x squared and 2x squared? Now at this point, I haven't set up my division in the structure that mathematicians typically use. I'm doing it solely through multiplication, but if I do the division on the side, you can kind of see how each step plays plays in. So let's match these and continue to think about this as a what was multiplied or what do I need next type of question. So we determined x squared right here, and then we got x cubed minus 7x squared. And we're asking ourselves, what's the difference between 2x squared and negative 7x squared? Well, that difference is 9, because negative 7 plus 9 is equal to 2. And then we need a common term. You can see that in my division, when I subtract these, 2 plus 7 is 9x squared. Okay, how do I get a 9x squared when I'm multiplying? What do I have to multiply x by to make 9x squared? Same question I ask here. What do I need to multiply x by to produce 9x squared? And the answer is, well, you need a 9x, because x times 9x is 9x squared. However, in multiplication, it's not just x times 9x, it's negative 7 times 9x as well. And that is negative 63x. That's a massive number. Okay? You can see that here in the division if we're setting it up, but I do need to bring down the negative 3x and the 4, and then I get 9x squared minus 63x. Okay, I don't want a 63x, I want a 3x. What's the difference between negative 63x and negative 3? If you answered 60, you are correct. I can subtract these numbers to find the difference. And the difference is 60x. Well, how do I get a 60x? What do I have to multiply x by to get 60x? I have to multiply x by 60. I'm not just multiplying x by 60, I'm multiplying x minus 7 by 60. So make sure, bring down that 4, we check the full multiplication. 60 times x, 60 times 7, 420. And again, x times 60 is 60x, we already have that. Negative 7 times 60, negative 420. I don't want negative 420. My final result only has a plus 4. What's the difference between negative 420 and positive 4? This difference, this final difference, is the remainder. I need an additional 424 added to the end of my problem to make everything line up. You can see this value if you subtract these. And if I were writing this as a division problem, you know I would write my answer as x squared plus 9x plus 60 plus the remainder over what I was dividing by. But if I'm writing it as a multiplication problem, my answer becomes x minus 7 times x squared plus 9x plus 60 plus a remainder of 424 is equal to my original polynomial. So hoping this view, this extra view as division, as unmultiplying or figuring out what was multiplied will help some of you understand the process a little bit better.